Hi, this is section 7.9 on partial fractions. So this is where we're going to decompose fractions. So usually we have two or more fractions and we combine them into one, but this time we're doing the opposite. We're going to take one fraction and break it into two or more fractions. So there are different cases, that's why you see all these different cases here. But in general, if the denominator is linear, then the numerator has to be constant. If the denominator is a quadratic, then the numerator will be linear. So that's just the general rule of thumb. So linear denominator means constant numerator. Quadratic denominator means linear numerator. So let's do this. So this one's already factored for us. So what we can do is separate the factors into two separate fractions, 1, 2. So that's going to equal 2. It doesn't matter which one goes first. I'm just going to get the x minus 2 first, but you could reverse those if you wanted to. And because those factors are both linear, that means that the numerators have to be constant. So a and b. You could use a sub 1, a sub 2, but I'm going to go with a, b, c, and so on. Okay, so that's it. So the number of factors in your denominator will determine how many fractions you have. All right, so now what we would do is multiply top and bottom by the missing factor. So for the first fraction, we are missing x plus 3 for the common denominator. For the second fraction, we're missing x minus 2. All right, so now we're going to distribute, and we should get ax plus 3a plus bx minus 2b all over our LCD. And now we want to group the x's together. So if you group them together, you're going to get ax plus bx. And then you group the constants together, 3a minus 2b. All right, and so with this, we're going to factor out the x. So you factor out the x. I'm going to factor it over on the right side. And for this, I'm not going to do anything special. I'm just going to put them in parentheses. All right. And so I'm going to write the common denominator again, which is x minus 2, x plus 3. On the left side, I'm going to bring this all the way down. The left side comes down. All right, so now we have this equal to this. Notice the denominators are the same, and notice that you have an x. So this represents a coefficient for the x term, and this represents the constant term. So we can write two equations, a system of equations. So a plus b must equal 8. So that's our first equation. And our second equation is, represents a constant, which is equal to -1. So 3a minus 2b must equal -1. All right, now let's do elimination. So I'm going to do elimination by multiplying this by positive 2. 2a plus 2b equals 16. This one's going to stay unchanged. Now you have elimination. You have 5a equals 15, which means a equals 3. All right, once you have a, you can substitute that into this equation, and you're going to have 3 plus b equals 8. 3 plus b equals 8. And so b equals 5. Once you have your two variables solved for, you can go back up to here, and you can erase what this part in red, and then replace the a with 3. So this becomes a 3. And replace the b with 5. And that is our final answer. We just decomposed the fraction on the left. We separated that into two separate fractions. So that's how you go about this. Let's try another example. Okay, for this example, we do need to factor the denominator first. You never want to factor the numerator. The numerator is just going to stay the same. The denominator will be x squared plus 2 on the inside and x on the outside. Okay, so now we're going to split this up into two separate fractions again, because there's two separate factors, x and x squared plus 2. All right, for the x, that's a linear, so therefore this has to be constant. For this factor, notice it's quadratic, which means the numerator must be linear, bx plus c. So that's a different case. All right, now we're going to multiply by the missing factor. In this case, we're missing x squared plus 2, x squared plus 2. And in this case, we're missing the x. So we're going to multiply top and bottom by x, x. Then we're going to distribute. So we have, I'm just going to work over here, ax squared plus 2a plus bx squared plus cx. All right, and now we're going to group. Let's group our x squares together. So we're going to bring the ax squared plus bx squared together, and the cx comes next, and then the constant goes last. And of course, we do have our LCD on the bottom still. Now we bring down the left side all the way down. Actually, before that, I'm going to factor out the x squared from those two. So let's do that now. A plus b, x squared gets factored out. And now I'm going to bring this left side all the way down. Okay, and so now we see that this coefficient corresponds to the 9, this coefficient corresponds to -3, and this constant corresponds to 8. So we have three equations, the first one being a plus b equals 9, the second one is c equals -3, and the last is 2a equals +8. So we can easily solve for a by dividing both sides by 2, we get 4. So we have c, we have a, now we just need b. So substitute 4 there, and you're going to get 4 plus b equals 9, b equals 5. Once you have a, b, and c, remember what we do. Let's erase this in red. And let's fill in or let's substitute in for the letters. So a is 4, and b is 5, and c is -3. So I'm just going to say 5x minus 3. That is our final decomposition. All right, the next one, notice it's already factored for us, the denominator, so we don't need to factor that. That's nice. So let's write these out. X minus 1, x plus 2, x minus 3. So there are three separate fractions, and they're all linear, which means that the numerators are going to be constant, a, b, and c. All right, let's multiply by the missing factors. In this case, x plus 2, x minus 3. I'm going to go ahead and expand that out. It's a little easier if you expand that out. So if you expand that out, that's going to be x squared minus x minus 6. Over here, multiply top and bottom by x minus 1, x minus 3. Expanding that out gives you x squared minus 4x plus 3. And over here, x minus 1, x plus 2, top and bottom. Expanding that out gives you x squared plus x minus 2. All right, now we distribute and group. So let's do the distribution first. Ax squared minus ax minus 6a plus bx squared minus 4bx plus 3b plus cx squared plus cx minus 2c. C is barely visible. Let me rewrite it. All right, now let's group all the x squares together. I'm going to group and factor at the same time. So a plus, whoops, that didn't show up very well. A plus b plus c, and then factor the x squared. So take care of that term, and that term. Now let's get the x's together. So always go with plus and then parentheses. So I have a negative a, I have a negative 4b, and I have a plus c with the x factored out. So I took care of that one. That was my negative a, my negative 4b, and my positive c. And then the last one is just the remaining constants, which would be plus again, parentheses, negative 6a, plus 3b, minus 2c. All right, so I took care of minus 6a plus 3b minus 2c. And on the left side, we have our rational expression that we just bring down. And of course, all of this is over the LCD as well. I just didn't write it out, but it is here. All right, so now let's go ahead and match up the coefficients. A plus B plus C is going to equal to 4. So let's see if I can squeeze that in over here. A plus B plus C equals 4. Let me try that again. A plus B plus C equals 4. And then the next equation is this is going to equal to negative 15. So negative A minus 4B plus C is going to equal to negative 15. And then for the last one, it's going to be negative 6A plus 3B minus 2C is going to equal to negative 1. All right, so you have a system. I'm going to use matrices on my calculator to solve this so that we can just save time. And you can also do that too. So feel free to use if you have a graphing calculator, to go ahead and use it. All right, so I solved it and I got A equals 2, B equals 3, and C equals negative 1. All right, so those are the three values for A, B, and C once you solve that system. So once again, you go back up to the red marking, erase it, unless you just want to rewrite it, which is okay too. It's up to you. And then change the A, B, and C to whatever values they are. So A is equal to 2, B is equal to 3, and C is equal to negative 1. And that will do it. All right, let's look at this one. This is yet another case. So this one, notice that there's a quadratic and then it's got an exponent. So in that case, you're going to go ahead and apply this rule here. You have a quadratic to an exponent. So you're going to, the first fraction is just going to be to the first power, and then to the second, and then to the third, fourth, so on and so on. So this one only goes up to the second power. So let's do that. So the first denominator will just be x squared plus 1 to the first. And the second one's going to be x squared plus 1 to the second. And this is quadratic, so that means we need to have ax plus b. This is also quadratic, so that's going to be cx plus d. All right, and so now we multiply by the missing factor. Over here, the only one that we are missing is a second factor of x squared plus 1 in order to make it squared. Squared plus 1. Notice for this one, we're not missing anything. It's already the LCD, so you don't need to multiply anything. So all we got to do here is expand that out by foiling. So if we do that, we're going to get ax to the third plus ax plus bx squared plus b, and then we have the second numerator all over the LCD. All right, let's do the grouping. So the grouping, there's actually, the only thing we can group is the c's, and let's write this in correct order. Ax cubed should go first, bx squared should go second. Then the x's, there's two of them. There's ax plus cx, I'm going to factor out the x, and there's a b plus d. So I took care of that one, those two, and the b plus d. All right, all of that is over our LCD. And we bring the left side all the way down. All right, and now we write the equation. So a must equal 4. That's nice. We don't really have to do much solving there. B is going to equal -1. A plus C will equal 4. And the last one is B plus D will equal 2. All right, so let's do some substitution. If A is 4, subtract 4 to both sides, you get C is equal to 0. So we got A, B, and C. The last one is D. We know B is -1. So if that's -1, you add 1 to both sides, and you're going to get D equals 3. All right, so that will do it. So let's go back up to the red markings. Erase, erase. Let's replace A and B with A is 4x minus 1, 4x minus 1. All right, and then cx plus d will be 0x plus 3. So the c is 0, which got rid of the cx term altogether. And that does it for this problem. And that concludes the section.